All right, today we're going to tackle a core concept in marine electrical engineering, generator synchronization. I know, it sounds super complex, but trust me, we're going to break it down using a surprisingly simple analogy that will make it all just click.
So what do two motorcycles have to do with powering a giant ship? It's a fair question, and the answer is, well, pretty much everything. This little comparison is the key to unlocking a really powerful electrical process. Just hang in there, and you'll see exactly what I mean.
Okay, so picture this. On a massive ship, you can't just have one generator trying to power everything. It's just not going to cut it. You have to connect multiple powerful generators together in parallel to handle the load. And that process, connecting them safely, is called synchronization. It is absolutely critical.
But here's the thing. You can't just walk over and flip a switch to connect two of these massive machines. No way. If their electrical outputs aren't a perfect match at the exact moment you connect them, well, the results can be pretty disastrous. Getting that match perfect is the whole game.
So, how on earth are we supposed to remember all these conditions for a perfect match? Well, believe it or not, by thinking about motorcycles. It might seem a little out there, but this visual is going to make the entire concept fall right into place.
Okay, let's paint a picture here. Imagine you're on a motorcycle, right? And your passenger needs to jump from your bike over to a second motorcycle that's riding right alongside you. The goal is simple: a safe transfer, nobody gets hurt. So, what needs to happen for that jump to work?
It's pretty obvious when you think about it, right? First off, both motorcycles have to be going the exact same speed. Makes sense. Second, they have to be perfectly aligned side by side. And third, the road has to be smooth. No bumps, no potholes, nothing that's going to throw you off balance.
And there it is. That's it. Those three simple, common-sense rules for a safe motorcycle jump are the very same three rules for safely synchronizing two massive electrical generators.
Okay, let's break this down, because this is where it all clicks. The two motorcycles, those are your two generators. The passenger jumping across, that's the electrical load. You know, the power being transferred. Matching their speed, that's the same as matching their frequency. Perfect alignment, that is matching their phase. And that smooth road, you guessed it, that's like matching their voltage. This right here, this is the mental shortcut you need.
All right, so now that we've got our motorcycle story locked in, let's dive into the technical side of things, one rule at a time.
So rule number one, frequency matching. You can basically think of this as the electrical speed of the generator. It's all about how fast its engine is rotating. For them to connect, their frequencies have to be identical, usually standardized at 50 or 60 hertz.
So how do you actually check this? Well, engineers use this cool little tool called a Synchroscope. It's pretty straightforward. It has a needle that tells you if the new generator is running too fast or too slow. The sweet spot, you want that needle to stop moving, right at the very top, dead center.
And boom, we're right back to the motorcycles. Rule one of the jump, right? Both bikes have to be moving at the exact same speed. It's the exact same principle for our generators. They have to match their frequency for a safe connection. No exceptions.
Okay, rule two, phase matching. Now, AC power isn't just a steady stream. It's a wave going up and down, up and down. Phase is all about timing, making sure the waves from both generators are perfectly in sync, that their peaks and their valleys are hitting at the exact same time.
You see, if you try to connect them when one wave is at its peak and the other is at its lowest point, you're essentially creating a massive short circuit. We're talking a huge, sudden surge of current and some really violent mechanical forces.
And just like that, we're back to our analogy. The motorcycles have to be perfectly lined up, side by side. If they're not, it's a disaster waiting to happen. It's the exact same thing with these electrical waves. They need that perfect alignment.
And that brings us to rule number three, voltage matching. The easiest way to think of voltage is like electrical pressure. It's the amount of push coming from the generator. Now, if one generator is pushing way harder than the other when you connect them, well, you get this huge, violent rush of power from the stronger one to the weaker one. Not good.
You know, a classic way they check this is actually with some simple light bulbs, called synchronizing lamps. You hook them up between the generators. When the voltages and phases are a perfect match, the lights go completely dark. And that's your signal. That's the moment you close the breaker.
And this is our smooth road, isn't it? A difference in voltage is like hitting a massive pothole. It's going to cause a huge jolt. But if the road is perfectly level, meaning the voltages are equal, then the passenger, our electrical load, can transfer over nice and smooth.
Okay, so we've talked about how to get it right, but what happens if you get it wrong? What happens when the jump fails or the sync goes bad? Well, it can get pretty ugly pretty fast.
Best case scenario, you just trip the main breakers and everything goes dark, a total blackout. But worst case, the forces are so intense they can literally twist a solid steel generator shaft, or just completely fry the delicate windings inside the machine. We're talking catastrophic, really expensive failure.
And believe me, this isn't just some textbook theory. The kind of damage that can happen is real, and it is devastating. It's a powerful reminder of why getting this right isn't just a good idea, it's absolutely essential for keeping the crew safe and the ship's power system in one piece.
All right, let's wrap all this up. I want to give you a super simple cheat sheet so that everything we've talked about really sticks.
At the end of the day, it's this simple. If you can remember the motorcycle jump, you've got this. Same speed equals frequency matching. Same alignment equals phase matching. And a smooth road equals voltage matching. Seriously, if you're studying for an exam, this little trick is golden.
And that really brings us to a final thought here. The power of a good analogy is that it makes something really complex feel simple and makes something you might forget stick. So the next time you're staring down a tough technical problem, just ask yourself, what's the motorcycle story for this one? Thanks for joining me.